Have you ever walked into a building and it just feels right? The temperature is perfect, the lighting is just so? Well, that's not magic. There's actually a hidden, intelligent system working tirelessly behind the walls. So let's pull back the curtain and take a look at the invisible brain that runs our buildings.
Okay, so take a second, look around you. Think about everything that's plugged in and using power. Your computer, the lights, maybe there's a TV on somewhere. What do you think is the single biggest energy guzzler in the whole place? Go on, take a guess. The answer is probably not what you're thinking.
Believe it or not, it's the very systems that keep us comfortable and let us see what we're doing. A building's heating, ventilation, air conditioning, and its lighting can account for a staggering 70% of its total energy use. I mean, just look at that. That is a massive slice of the pie.
So if all those systems are the muscles of the building, doing all the heavy lifting, what's the brain? What's the thing that coordinates this huge energy symphony?
It's called a building management system, or BMS for short. And the best way to think about it is as the building's central nervous system. It's this integrated, computer-based platform that watches over and controls pretty much everything, from the air temperature to the security systems, all from one central hub.
And here's why this matters so much. The stakes are really, really high. When a BMS is set up or programmed the wrong way, it can be responsible for up to 20% of a building's total energy waste. So getting this invisible brain to work perfectly isn't just a nice-to-have, it's absolutely crucial for efficiency.
But, to really appreciate this amazing technology, we got to go back in time. I mean, way back. Back to an age before any of this automation existed, when keeping a building comfortable was all about pure muscle.
Before any of these automated systems, managing a big building was just an incredibly tough, labor-intensive job. We're talking about an army of staff whose entire role was to run around and tend to individual fireplaces, and in some cases, their job was literally to fan castles just to keep the air moving. It was all manual, completely reactive, and totally dependent on someone being there to do the work.
So how in the world did we go from fanning castles to smart buildings? Well, it all started with a few sparks of genius, a few key inventions that basically laid the groundwork for everything we have today.
The first real leap forward happened way back in the 1600s. A guy named Cornelius Drebbel invented a primitive thermostat. Now, it was for keeping egg incubators warm, but it introduced this revolutionary idea of a device that could automatically react to its environment. Fast forward to 1884, and Thomas Edison gives us the safe modern light switch. And this was huge, because for the first time you could safely control a building's electrical system. Then in 1902, Willis Carrier invents modern air conditioning, which finally gave us the raw power to actually manufacture an indoor climate.
But even with these amazing breakthroughs, those first attempts at controlling everything were incredibly clunky. The source material we looked at describes them perfectly as mechanical, time clock-style control systems. Just picture these giant physical timers that you'd have to wind up, and they would just turn things on or off at a set time. There was zero nuance.
And that really shows you the tale of two eras, right? Manual control was just this constant state of reactive firefighting. You're literally running around, putting out fires, adjusting a valve because a room got too hot. The goal of automation was to get to predictive regulation, to create a system that could hold a precise temperature, a set point, with almost no fluctuation, all on its own.
And that was the really big challenge. I mean, it's one thing to invent the hardware, like a valve or a fancy switch, but it's a whole other thing to invent the logic that lets that hardware make its own decisions. So, yeah, how did we teach machines to think for themselves?
The answer, it turns out, wasn't mechanical at all. It was mathematical. We had to literally create a brain for the machine.
And here it is. This is the crucial bit. In 1925, an inventor came up with something called the Proportional Integral Derivative Controller, or just PID for short. Now, I know that sounds super complicated, but just think of it like the cruise control in your car. It's constantly measuring your speed, comparing it to your target, and making these tiny little adjustments to the gas to keep you right there, whether you're going uphill or downhill. This algorithm did the exact same thing for temperature, and it was a total game changer. It became the gold standard for control logic for decades.
And here's a little piece of trivia for you. This brilliant piece of math that would one day run all our buildings, it wasn't even designed for buildings. It was first invented for the automated steering of ships on the ocean. It just goes to show how a powerful idea can find a home in the most unexpected places.
Okay, so we've got the mechanical parts, and we've got the mathematical brain. How did we put them together?
Well, for the first really big wave of building automation, the answer, surprisingly, was air. Yep, from the 1930s all the way into the 1970s, pneumatic systems, systems that use compressed air to send signals, they were king. And why? Well, a few really good reasons. They were relatively simple, they were incredibly durable, and maybe most importantly in old buildings, they were super safe because they didn't create any electrical sparks.
And the way it worked was just beautifully simple. First, you'd have a central compressor creating pressurized air. That air would then travel through this whole network of little tubes to a thermostat on the wall. That thermostat was basically a tiny, sensitive valve that regulated the air pressure based on the room's temperature. That tiny change in pressure would then move a little device called an actuator, which in turn would physically open or close a valve or a damper. No complicated electronics, just pure physics.
And that right there was the state of the art for almost half a century. We had officially gone from relying on human muscle to the power of compressed air. This was the true dawn of the journey, the real foundation for the smart, digital, super-efficient buildings that surround us today.
So, the next time you walk into a room and the temperature is just perfect and you don't even have to think about it, stop for a second. What invisible systems will you think about now? Will it be that little PID controller doing its math in the background, or maybe the long history of air-filled tubes that came before it? Because behind all that comfort is just a fascinating story of human ingenuity.